Hello. We are going to repeat the same thing for the probing model. So in probing model, the syntax is the same. Probe it instead of regress. I use probe it and regress employed on age and female. And you may use robust. Then we get result. Interpretation is similar. But remember, in the probing model, this coefficient is the effect of age on z-value, z-index, not the probability. That is the main problem. So it does not imply the intercept probability. The probability at 0 is not 97%. It doesn't make sense. So female has -1 effect on z-value. It's hard to tell what is the meaning of that. So here here what we can tell from this is that okay, female has a negative effect, age has a positive effect, and age is significant like p-value is 0.9%, so it is significant, and female is also significant, p-value is 2.2%. so just by coincidence, those p-values are the same as what we had in the linear regression earlier. So this is just by coincidence, but also reasonable because we are using the same data and same set of regressors. But it is just by coincidence, as you can tell. The t statistics are different. T statistics are slightly different here. So it's just coincidence. Anyhow, I will show you how to predict the probability. And to do that, I deleted earlier, so I will define 3 non-existent observations. And so this is probability by linear regression. Linear probability model. I will use the same post-estimation prediction option, prediction probability. Now we will use probing model. So then you may choose one of them. So if you choose number 2, it will calculate the z-value, but means nothing. So we will use the probability of a positive outcome. So probability of 1, probability of employment. So this is exactly what we would like to calculate. And okay. And then you see that probabilities, probing model estimates are given here. So probability model is given here, and these numbers are predicted probability. So probability predicted by the probing model. So you may use these numbers. This is very simple, a simple trick. But if you try to do it by hand, it is not easy, because if you use these numbers, you can get the z-value. So age is 30, so 30 times this, plus female 1 times this, plus the intercept. Then you will get the z-value. After that, you have to take the standard normal distribution function. It is possible, but it's not. It is also very cumbersome. So I think using the additional observations, making dummy observations would be the simplest way to handle this problem. And now let's compare the prediction from the linear regression model and the probing model. For example, they are of course different. They are different, but similar. They have the same tendency, because the estimates are like age is still in both models. Age has a positive effect, and female has a negative effect. So the directions direction is the same in two models. Therefore, the probabilities are similar. However, if you look at, for example, this guy, the difference is larger if the linear probability model approaches to 1. If the probability is closer to 1, say here 90%, then it tends to be flattened by the probability model. So the probability differs a little bit by the differences linear model or the nonlinear smooth model. So by that much you see the difference. So let's look at this guy. So for this guy who is the youngest in our data has similar probability. So in this case they are not, so the linear model and the nonlinear model are not much different at this point. So the difference increases as the probability approaches to 1. So you may find the pattern. And also, prediction can be done in this way. Another thing I would like to show you here is the coefficients are not interpretable. So they have no direct meaning. The numbers do not have any meaning. Therefore, we would like to transform these coefficients into the marginal effect. So what we want is the effect of additional age on the probability of employment. So we can calculate that, like that effect is called marginal effect. To do that, we go to post estimation again and use marginal effect of all covariates. So this is what we are going to do. So we are going to transform all coefficients into marginal effect. You may choose anything. So here there is no difference between them. I will choose the first one. You may choose one of them. Anyhow, we are going to calculate the average of calculate the probability on the average person in the sample, average marginal effect. So this is the average. So now then it shows the effect of age on probability and effect of female on probability. Look at this. Age, the effect of age is about 0.1%. Female is about -2%. This is different from this. A little bit different, like about 5 times larger here. But now compared to the OLS estimate, it's similar, 0.1%, -2%. So the OLS coefficients capture the direct effect on the probability, which can be compared to those marginal effects. So marginal effect command is this. So the reason, like here, star is used. You may use like this. If you use one specific regressor, then it calculates the marginal effect for one variable, one regressor specified here. But if you want to calculate the marginal effect for all the regressors, use star. And dy dx means the derivative dy over dx. So the typical derivative notation. So this is the command you can obtain the marginal effects. And these are comparable to the OLS estimates. And what we did can be done in the same way for logit model. So if you run a logit model, we use the same robust option, and these coefficients are even more different. So these coefficients, remember, female's coefficient is -0.18, which is near twice larger than the probit coefficient. They are different because the nonlinear functions are different. However, they are not comparable again. So the z index in the probing model have a different scale from the z index in the logit model. So two models will have, it's natural to have different scales in their coefficients. This is not a problem. Now I am going to predict logit PR, maybe. I'm not so sure if my command is correct. So P, P. So using this predict command again, you can obtain logit estimates. So even if the coefficients are quite different, but their estimates are very similar. Look at them. So almost in all cases, they are very similar to each other. And the reason is, as you see from the lecture, they are both similar curves, and if you go down, you obtain the predicted probability for these three ages. So you may use the same tricks to calculate the predicted value for logit. Again, and then if you type this is the command for the marginal effect. If you type this, you get marginal effects from the logit model. Remember, these two commands are post-estimation commands. So that means to implement them, the outcome of the estimation must remain in the memory. So now in the memory, most recent estimation result is saved. So these commands are based on the logit model, the most recent estimator. Therefore, these are marginal effects for the logit model, and again, it is quite comparable, pretty similar to the previous results. Age has an effect of 0.1% and female has -2%, which are similar to the numbers we obtained earlier. This is how we interpret the logit and probing models. And in the next video, I am going to summarize those commands into a do file, so that in the do file you can make a table, and then that may help you. And to help you how to do the do file, I will show you how to make a do file in the next video. See you later. Bye.